All right, hey guys, section 1.6 is all about congruence. So, figures that have the same measure are called congruent. The symbol for congruence is an equal sign with a little squiggly above it. All right, in a figure, we use tick marks to show congruent segments. So I'm going to jump down here and actually show you what that looks like. So if I have this segment, and I've got ABC, if I want to say that segment AB is congruent to segment BC, then all I have to do is put a little tick on each one, and I show you that they're the same. All right. You can do a variety of different things with tick marks. You can do one tick mark, two tick marks, whatever. If I want to do XY, segment XY is congruent to segment YZ, then I could actually even just put two tick marks like this on both of them. As long as you put the same marking on the ones that are congruent, you'll be good. You don't want to put one tick mark here and two tick marks here. That doesn't show me that they're congruent. It actually shows me that they're different. All right. Then we've got arc marks to show congruent angles. So if I have an angle like this, A, B, C, and D. So if I want to say that angle ABC is congruent to angle CBD, then I can put arc marks to show that. So I'm just going to put a little swoosh in one of the angles and then a little swoosh in the other angle. A lot of times I actually do a swoosh with a tick mark in it, like that, to show it. You could also just do the swish. You could do two swishes. Again, as long as it's the same in both of them. So we'll talk about a bunch of different markings you can use, but that's the gist of it. We've got tick marks for congruent segments and arc marks for congruent angles. All right. So let's talk about a midpoint. So the point that bisects or divides a segment into two congruent segments. If M is the midpoint of segment AB, then segment AM is congruent to segment MB. So for example, if I have this segment AB and M is the midpoint, then I know I can put tick marks to show that AM is congruent to MB. So segment AM is congruent to segment MB. And congruence just means that they have the same length. So we could also write then that AM is equal to MB. Because remember, writing those without the segment bar above it means the length. So this is like saying the length of AM is equal to the length of MB. Whereas up here we're talking congruence. So AM is congruent, segment AM is congruent to segment MB. So this is just another notation thing that we're going to have to talk about. But that's what the picture would look like. Then we need to talk about a segment bisector. So a segment bisector can be any point, segment, or line that intersects a segment at its midpoint. So for example, if I have that same picture from above, and I have A, B, and M, and I know that M is the midpoint, I can draw a line through it, and let's just call that line L. if I put tick marks here to show that AM is congruent to MB, then I can say that line L bisects segment AB because it crosses it at its midpoint. We'll have a bunch of different pictures for that as well, but that's just one example that we can look at. All right, so then we have an angle bisector. So a segment bisector obviously means that a segment is being cut in half. An angle bisector then means that we have a ray that's dividing the angle into two congruent angles. And remember, if you have a bicycle, it's got two wheels, so a bisector cuts it into two congruent angles, or two congruent segments. All right, so if we have ray JK and it bisects angle LJM, we know that angle LJK is going to be congruent to angle KJM. So if we were to draw a picture of that, we know that JK is bisecting angle LJM. To show that we know that's a bisector, we have to put those arc marks. So if you put a swish here and a swish here, then we show that those are congruent to each other. Without those marks in there, without those arc marks, you're not showing me that that's a bisector. You're just telling me that K is on the interior, and that's different. All right, so make sure you've got those marks in there too. We're going to do two quick examples. Very similar to section 1.5, you have to read directions here, guys. I know it's not your thing sometimes, but I'm trying to get you in the habit, all right? The first thing we're going to do is draw and label the picture. And I even reminded you, don't forget tick or arc marks. So if you read the directions, I even give you hints in there. Then use angle or segment addition to write an equation. So that's going to be the second part. And then finally, substitute the given values or expressions and solve. So again, it's a three-part thing just like in the last section. D bisects segment EF. So the very first thing we're going to do is draw ourselves a picture of what's going on. D is bisecting segment EF, which means D's got to be in the middle, and we have to put some tick marks to show that we know D is bisecting it. We know bisect means two congruent segments. So it might help to actually write that. When you see bisects, tell yourself, oh, two congruent segments because we're bisecting a segment. All right, then let's label what else we know before we write our equation. We know that ED is 4x plus 6. So that's this portion right here is 4x plus 6. And then we also know that DF, so that's this portion, is 7x minus 9. And that's all we were given, so that's all we can label. But notice that our picture has the points labeled, it has the the tick marks, and it has both of the expressions labeled correctly. So now we need to think about what kind of an equation we can write here. Well, we know that ED is congruent to DF. Segment ED is congruent to segment DF. We also know that the length of ED plus the length of DF has to equal the length of EF. So we need to decide what actually goes here. Well, in this particular problem, we're only given the two small pieces. And so we don't really have anything where we could say, oh, ED plus DF equals EF. So we can't really use this equation right now. But what we can use is that ED, segment ED, is congruent to segment DF. And we know that that actually means the length of ED is equal to the length of DF, which means we actually luck out. All we have to do for this one is set those two equations equal to each other. So 4x plus 6 is going to equal 7x minus 9. And we can solve for x. We want to get our variables on one side, so I'm going to move the 4x over here to make it 3x minus 9 equals 6. Add my 9 over to make it 15 equals 3x. And then divide by 3 to actually get x equals 5. Now we have to be careful because this question just asked us to find ED, DF, and EF. It didn't even ask for x as an answer. Now we need it in order to get to our answers, but that's not going to actually go on our lines here. So let's find ED first. We know that ED is equal to 4x plus 6. And since we know that x is 5, we can substitute that in. So we get that ED is 20 plus 6. So we know that's 26. So I'm going to go ahead and write that on our first blank. ED is 26. Then we can find DF. So we know that DF is 7x minus 9. So 7 times 5 minus 9. And we get 35 minus 9. So we get that DF is also 26. And hey, that should work out like that, guys. That's actually how we know that we got this right, because when we plug it into both of those equations, we get that they're the same length. That's what should happen because D is bisecting the segment. All right, then we also need to find segment EF. Well, we already said we could use this equation, that EF is the sum of both of them. So if we add those together, we know that EF is just 26 plus 26. So EF has to be 52. All right. Our work is, there's a lot of work there, right? Like we needed to figure out which equation we were actually going to use, then pick that equation, plug it in, and plug in what we know so we can solve for x so that we can plug it back in and get to it. But I promise by writing it all down, it's going to help make sense later on when you're doing these problems on your own. Okay? One more example and then you'll be done. So QS bisects angle PQR. So your first step should be draw yourself a picture. The angle's being bisected by QS. So I always draw that in. And it's bisecting angle PQR. Now that's not the only thing for my picture. If it's bisecting, I know that I'm going to get two congruent angles. All right, so my two congruent angles, I'm going to mark those then. I know that PQS has to be congruent to angle SQR. Now, if you notice, on this one, I put a swish and then I put two tick marks through it. It doesn't matter. It doesn't mean anything different than if you just put one or if you just put one swish. All right, I'm just trying to show you guys some different notation there. Let's see what we know. We know that angle PQS, so PQS, that's this part, is 5y minus 1. And then we also know that the measure of angle PQR, so PQR, that's the whole thing. So the measure of angle PQR is 8y plus 12. We need to find the measure of angle PQS. All right, and y so that we can plug it back in and figure out what this angle is. Looking at this one, we have two options again. We know that we've got congruent angles. So those congruent angles, we know angle PQS is congruent to angle SQR, which we know means the measure of angle PQS has to equal the measure of angle SQR. So if this one were 15 degrees, this one would have to be 15 degrees. So we need to think about that. But we also know from our angle addition that the measure of angle PQS plus the measure of angle SQR has to equal the measure of angle PQR, the whole thing. So that's from our angle addition. Well, we need to figure out which equation actually makes sense here. So if I want to set PQS and SQR equal to each other, I need to know what angle SQR is, and I don't. But what I have is a part, and I have the whole. That's what I know then tells me this is the equation I need, because I know that part plus part has to equal whole. So this is the equation I actually need. So we can write it up there again, the measure of angle PQS plus the measure of angle SQR has to equal the measure of angle PQR. But don't worry, we didn't write this for nothing. All right, the measure of angle PQS has to equal the measure of angle SQR. So if angle PQS is equal to 5y minus 1, that means that the measure of angle SQR also has to be 5y minus 1. They have to be equal to each other. Now I can actually use this equation and plug in what I know to solve for y. So PQS is 5y minus 1. SQR is 5y minus 1. And PQR is 8y plus 12. So now that I have my equation, I can go ahead and start simplifying and solving. So 10y minus 2 equals 8y plus 12. If I move my y's over here, I get 2y minus 2 equals 12. Add 2 to both sides to get 2y equals 14. And then divide both sides by 2 to get that y equals 7. Now this one didn't ask for y as the solution either. It asked for the measure of angle PQS. So PQS was that original one that we were given. The measure of angle PQS is equal to 5y minus 1. And we know that y is 7. So 5 times 7 minus 1. We get that the measure of angle PQS is equal to 34 degrees. Make sure when you name angles, by the way, or when you give me the measures of angles, that you include the degree symbol. I don't know if I talked about that earlier. I'm sorry if I didn't. But please make sure that that is included. I know this was kind of a lot for a video. I know that these involve a lot of writing, but this is kind of why we focused on just writing those equations first, and then we're now adding in the algebra part. So hopefully that made sense. If you have any questions, I hope you wrote them down, and we'll talk in class. I'll see you guys later. Bye!